Okay, I start my talk by saying why we are interested in working with review summarization. Basically, nowadays, if you want to buy something on the internet, or if you're interested in buying some products, you can see a lot of reviews on that product, different resources. For example, you go to Amazon website, you can see for this Kodak camera, there are around 800 customer reviews. So browsing and going through all these reviews and reading them, you definitely face information overload problem. So one of the ways to overcome somehow this problem is to go for summarization. So summarizing all these reviews into a paragraph or two. Starting review summarization was extractive. So extractive review summarization, the systems try to extract sentences that are important or significant in the original reviews and then present them to the users as extractive summary of those reviews. For example, in this, for this Kodak Yashar, Amazon produced this review. The camera is easy to use and takes clear and quality picture. In addition, support of the item was no longer available. I returned the camera. This is the extractive review Amazon produces. And you can see the review. While it's useful, but it's not coherent. At the same time, you don't see any aggregation of opinions here. And also, it doesn't express the distribution of opinions. So there are some problems here that abstractive review summarization can somehow overcome and solve. So abstractive review summarization try to generate the summary based on the reviews. Looking at the same example, you can see this abstractive summary while the red fonts are the aspects or the features of the camera. And then you can see that it's much more appropriate based on actually the literature proof that it's more appropriate for reviews to go for abstractive summarization. You can see it's much more coherent. You can see that it aggregates the opinions, so you can see the aggregation of opinions for each aspect. At the same time, you can see the distribution of opinions, like 24%, all reviewers. So we are convinced that abstractive summarization is better than extractive summarization. Previously, there were a few works that tried to approach abstractive summarization of reviews. The first approach is a graph-based method, and they try to generate ultra-concise, phrase-based opinion summaries. It was very good because of visible and small screens, but at the same time, there is no sentence generation, so the abstract is not really generated. And also, you cannot see any opinion distributions. To overcome such problems, the next approach tries to use aspect ontology and also opinion distributions to generate well-formed sentences or paragraphs as the abstractive summary. Of course, it was grammatical and it showed opinion distribution, but at the same time, they had to use aspect taxonomy. So if you want to use aspect taxonomy for each product, you have to rather build it manually, which is really time-consuming, or you have to do it automatically, which is noisy. So the very recent work tried to embed selling codes from input reviews and somehow transform it in a supervised way to abstractive summaries. They didn't need any aspect taxonomy. So on a plus side, they didn't use aspect taxonomy, but on the minus side, they had limited number of aspects as input, so their approach was limited to the number of aspects. At the same time, since their approach was supervised, they need a large training data. To overcome the limitations that I mentioned here, what we propose in this work is that we can use the rhetorical structure and rhetorical relations in reviews to generate these abstract summaries. So our core claim is that this information, the rhetorical information, can help us to infer the importance of aspects, at the same time, the association between aspects. Once you have this information, you can pass it to a natural language generation framework and generate a summary. So in this way, our approach is grammatical and coherent. It shows opinion distribution. We don't need any aspect taxonomy. Is not limited to number of aspects. At the same time, it's totally unsupervised, so we don't need any training data. I show you our framework briefly, and then I go to each step one by one. So in the first phase, we try to run discourse trees, or discourse parser on reviews. We generate discourse trees for reviews. We merge them together. We generate the whole big graph. In the next step, we try to extract a important subgraph from that big graph, and then we transform that into aspect hierarchy tree. And in the third step, we pass that hierarchy tree to the natural language generation framework, and we generate our summary. So I start by saying, I talk about discourse structure and relation. So I show you in one example, what do we mean by discourse structure. We have one review here. The discourse parser tries to segment the reviews at first to elementary discourse units, or EDUs, and then finds the relations or rhetorical relations between EDUs and shape a tree. So EDU, in this example, EDU2 and EDU3 are in elaboration relation with EDU1. At the same time, each node, which is EDU, is labeled by nucleus or satellite. Nucleus nodes are the central point of the message, and satellite nodes are the peripheral ones. So we have a lot of reviews. We run the discourse parser on the reviews. For each review, we generate one discourse tree. Now we have a set of discourse trees. In the next stage, we want to capture the association between the aspects. So for each EDU, we filter the words that are not related to the aspects, and we keep only aspects. So for each discourse tree, we generate aspect discourse tree. At this stage, we have aspect discourse trees for all reviews of our product. You can see aspect discourse trees here. But aspect discourse trees are kind of noisy because we are using automatic methods for discourse parsing. In order to reduce this noise, we aggregate all these aspect discourse trees together. And what we aim by aggregating these aspect discourse trees together is that we want to find which aspects are heavier or more important for us, at the same time, which relations or rhetorical relations are higher rated and are linking these aspects together in a heavier manner. So for this, we try to extract the relation tuples from the tree. We rate each relation by the position of the relation in the tree, and also by the proximity of the aspects that the relation connects. And then we have a set of relations for each aspect discourse tree. We get these aspects, rhetorical relations. We aggregate them, merge them together. We create a big graph we call aspect rhetorical relation graph, or ARG. So basically, this ARG represents all aspects in the reviews and the relations between these aspects. So in the next stage, we want to, since we are aiming at summarization, we want to select a part of this graph, and we want to transform to a structure. So looking at this graph, we see that aspects are weighted by how frequently and strongly appeared in our reviews. At the same time, edges are weighted by how strong and how frequently they link our aspects together. So what we want to do in the content selection, we want to select a subgraph that shows us the important aspects, at the same time, the very heavily linked or associated aspects. So a common approach to such problem is a page rank. We run page rank, what we extract is a subgraph. This subgraph shows us the important aspects and heavy relations or associations between the aspects. We have this subgraph that we extracted. So what we want to do, we want to navigate over these aspects. At the same time, we want to know the hierarchical relations of these aspects. So we want to know which aspects is the root, which aspect is the children, which aspect is more general, which aspects is more specific. So we want to know this because this information can be used in our generation framework. So we run the minimum spanning tree, and then we produce with the highest weighted root, with the highest weighted aspect as a root, we generate the aspect hierarchical tree. So you see in our aspect hierarchical tree that the camera is the root or the most general aspect or the product itself, and then once we go to the children's, it gets more specific. And also we can see the strong associations between the aspects. We have this aspect hierarchical tree. We send it to our natural language generation framework. Our natural language framework is a template-based framework. Like other natural language frameworks, we have the first step of macro planning, where we try to select our lexical terms. So lexical choice is decided here. We have quantifier, polarity verbs, connectives. We have a lot of cases. For quantifier, we look at a relative number of people who talk about this aspect and find the lexical term for quantifiers. For polarity verb, we look at the mixed opinions or average polarity, and then we find our verbs. For connectives, we look at polarity agreement, we look at relations, we look at number of children. We have many cases. We find our best connectives, and we pass our lexical choices to the sentence realization step. Sentence realization step, we had many types of templates. So we have a lot of cases for templates. We try to fill our lexical choices in those templates and generate our sentences. How we do that? Well, the details of our templates are in the paper, so I just walk you through this example to show you how we do the sentence planning. So imagine we have one aspect hierarchical tree here that we obtained in the previous step. We start by the highest weighted aspect, which is the camera. We say we have our lexical choices here. All reviewers, quantifier, who commented on the camera thought it was really good. Polarity verb is selected. Then we go to the highest weighted child of the camera, which is photo quality. We see the polarity agrees. We continue the sentence by mainly because of the photo quality. We go to the next child. We have control. We see control is controversial, so there's mixed opinion about it. We say that accordingly about 20% of the review commented about the control, and they had mixed opinion about it. The children of control, we see that there are two children for control. We go first to the highest one, highest weighted one is auto mode. We say also related to the control because it's the children of control. 7 users expressed their opinion about the auto mode and they liked it. You see the polarity is plus. And we go to the next one. When we go to setting, we see the polarity doesn't agree because it's minus at the same time the relations in contrast. So we use a connective in contrast. So we say in contrast, 6 shoppers commented about the setting and they didn't like it. So that's how our framework try to generate the summary from rhetorical relations of the reviews. We evaluate our systems on a data set consisting of 12 different products. We have 3 baselines. 2 of them are extractive. One of them is state-of-the-art extractive summarization system for reviews. And one is very simple abstractive baseline. So we try to rank our aspects based on their importance. And we choose only quantifier and polarity verb, and then we generate simple abstractive. And for our evaluation, we use pairwise preference evaluation using crowdsourcing. We run 2 user studies. In user study 1, we show the reviews to the raters, and then in user study 2, we don't, in user study 1, we don't show the reviews to the raters, and in user study 2, we show the reviews to the raters. We have a lot of qualitative, quantitative analysis on our results, but I show you the most important one, and then I leave the rest for you to read in our paper. We can see our system significantly outperform other systems in overall preference in both user studies that we have run with not showing review and showing reviews. One of the things that we realized when we showed the reviews, although we thought that it might not be effective, but still, when we showed the reviews to the raters, the agreement increased. We didn't stop our evaluation here. We have run qualitative analysis. So when the raters try to select their preference, we ask them to justify their preference. So they had to write why they prefer one system over the other one. So they preferred, so we try to analyze and categorize the reasons to understand why they like our system more. So they preferred our system more than extractive one because our system was more readable, the summaries generated by our system. We had better coverage over aspects. We showed the aggregation of opinions. At the same time, they liked our system over the simple abstractive one because we had the relations in our system, and we used those relations to connect, to choose our connectives and connect the sentences in a more fluent way. And also because of the more language variability. So you can see the examples that how they write their preference. And also in few cases, they preferred extractive systems over our system. Why? Because they said that it's more descriptive, or it shows personal point of view, or it shows some product capabilities. So, and also sometimes they like the simple abstractive one because it has simpler structure and it can cover more aspects. So these kind of analyses can really help us to further extend our approach and use these kind of analyses to improve our natural language generation framework and approach. In conclusion, what I presented here was a novel framework for abstractive review summarization. We rely on discourse parse trees or discourse structure of reviews. We aggregated all discourse relations into a graph, and then we run PageRank to select a subgraph. And then we try to transform them to a structure tree. We sent that to our natural language, template-based natural language generation framework, and we generated our summary. We run 2 user studies. We have done quantitative and qualitative analysis. In our result, we show that our system significantly improve other baselines in our evaluation settings for both user studies. And also, I invite you to download our evaluation data and summaries that are available in our webpage. For the future work, well, one of the first things that we want to do for future work is to improve our natural language generation framework. How we want to improve that, the first thing comes to mind is that, okay, we have the rhetorical relations between, as association between the aspects. So we can use those to select our connectives in a more smart way. So for example, when we have cows as a rhetorical relation between 2 aspects, then we can use some connective like consequently or as a result, or when we have a summary as a relation, we can say, in other words, yet. And also, we try to develop and evaluate an end-to-end automatic system. At this stage of our work, the aspect extraction and polarity estimation is what we have in our data set. So we use the gold standard since we are focusing on summarization. But we are trying to replace that with automatic aspect extraction, automatic polarity estimation, and evaluate our end-to-end system to see how the result changes and how we can cope with all those kind of noises that come from automatic methods. So that's all I wanted to talk about our approach, and I will be happy to answer your questions now. Thank you.
Any questions?
So I did not quite get the intuition when you connect the aspects using the discourse tree. And the other question is, you did not compare with the Carenini et al. Summarizer with evaluative text?
Okay. For the first question that you ask, why we use discourse structure and to...
how did you do that? You probably, like, I probably missed the...
Well, we run the discourse parser over the reviews, and then for each edu, we only kept the aspect. Then we aggregate all those relations that we can get from those aspect trees, and then we generate the graph. So how we generated the graph for each relation that we had, which is aspect, and relation between them, we generated 2 nodes in the graph and the relation between them as edges in the graph. So when the next relation is added, then the weight of aspect increases and the weight of edges increases. If there is no existent edges or aspects, the new edge and aspect is added. So that's how. And then we selected subgraph, and then we transform that to a tree shape to use it in natural language generation framework. Did I answer your question?
Yeah.
Okay. And for the next question about the evaluation, the point of this work was that we don't need aspect taxonomy, right? So how we can replace that aspect taxonomy is difficult to build. And also is, if you want to build it manually for each product, you have to build that, is to use rhetorical structure. So it's very much motivated. That's why we only use the extractive mid-star method as a point of comparison for our system.
Thanks a lot for the very interesting talk. So,
thank you.
The way I understand it, so you run an RST discourse parser, which has been trained on something else, I guess WJ or something, which is fully grammatical and everything. So I can imagine that some of the reviews might be ungrammatical. So how sensitive is like this approach?
Very interesting question. All point of aggregating all those rhetorical structure is that when we have noises, we are hoping that these noises reduce when we aggregate. So the ones that are more frequent happen are the ones that are more likely to be the correct ones. So we increase the weight of them, and then at the end we select them in the page rank, in the content selection and structuring. So the point that we try to do the aggregation, one of the motivation is to reduce that noise. But anyway, that noise exists. So our point was that, okay, if we use this approach and we try to aggregate, we still can generate reasonably well summaries that is preferred over the previous ones and extractive ones.
Thank you.
There's time for one more question. Okay, I do have one question.
Sure.
Maybe I missed something. I thought that you're already using those connectives based
Yes. Well, we use the connectives in a different way. So we don't use the connectives exactly to select the rhetorical, to select our connectives, but we check if the relation is actually, we explain that in detail in our paper. For example, here in this example, I show you here. So we look at the setting, we see that setting disagrees with our mode in terms of polarity, and also relation is contrast. So we use it in that way, and we select our connective as in contrast. But we don't go over, for example, we don't look at elaboration over that when we traverse from camera to photo quality and say, okay, this is elaboration, for elaboration we use disconnective. So we think that in future we can expand and extend our work, and then it's not very trivial, but we believe that we can use those rhetorical relations for having a better lexical choice for our connectives.
All right, let's thank Yashar again.
Thank you.